All right, I want to take some time to go over laboratory exercise 2. Now, I wrote this, so I take responsibility for it. I want to make sure I show you visually what you need to do so that you do well on it. And with that, I spent some time explaining a bit about our topographic maps and contour lines, which of course are imaginary lines that represent areas of equal elevation. Elevation is the distance above sea level across the Earth's surface that we see. And the contour interval is the difference in elevation between contour lines on a topographic map. I want you to review these rules that we have for contour lines, generally accepted rules. So every point that you see on a contour line has the same elevation. So let me just, I know for a fact that my mouse is offset when I use this monitor, so I can't really trace it. But if you look at the figure on the bottom, you can see these lines. Some of them are darker contour lines, but those are representing lines or areas of equal elevation on these mountainsides. And it's a very strange area we're looking at here in western Montana. But every fifth contour line is dark. We call that an index contour line. Contour lines will separate uphill from downhill. They do not touch or cross each other except at a cliff, and we won't really deal with that in this exercise. There are contour lines that might be like a circle with marks on the middle, on the downhill side of the contour line. That means the structure looks like a hill, but it has lines pointed inward to show you it's a depression. So we see that in figure 3. This is the reality of the structure. And then the marks show us, we were just looking at this on the map, that it is going down. It's a depression. Let me think about. This is also important. Contour lines create V patterns when they cross a valley or a drainage, and the tip of the V always points downhill. Or uphill. The tip of the V always points uphill. Example here. Again, I apologize for my mouse. I know it's offset. But if you look at this figure, there's a blue line for a river. You can see the Big George Gulch as well. And then the tip of the V is pointing uphill. Contour lines also create a V or U pattern when they cross a ridge. In this case, we have, like on this leftmost side, we have a ridge. And that is pointing downhill. Contour lines on opposite sides of a valley or ridge occur in pairs. We see that on either side of this kind of mountain structure. I chose this Patrick's Basin topographic map because I actually had to spend a lot of time here among the grizzly bears and mountain lions and who knows what else. So this area is familiar to me along the Gibson Reservoir, and it's got just the strangest topography, so I thought, why not introduce you to topographic maps through it? And I have the file, of course, in the lab. We'll go over this too. You'd see this on a map, right? Looks like eyes or something staring at you with these lines of equal elevation. But if you saw it in 3D, this is what it would look like, these pointed structures. And I did use REI quite heavily in the intro because they have easy to understand information. I know it's a recreational equipment store, but I think they're pretty good at what they do with the educational information. And sentimentally, I used to live next to one. Definitely don't now, so I don't know. Just something personal that I thought would be helpful. So make sure you watch that REI video. So for part one, you will open the Patrick's Basin file and look it over. And if you have any trouble with files, please let me know. I'll just bring up mine if I could. Patrick's Basin file. So I'm just using Windows. I use Mac as well. I use all of it. This should work on either or. We're looking at the Gibson Reservoir and this crazy topography. These are just basically ridges. They call this the sawtooth range because it looks like, in profile, it looks like teeth of a saw, right? Um, and so you're constantly going up and down and up and down if you were just to walk from east to west. Again, there's a lot of grizzly bears out here. It's kind of scary for me, but I had to do it, so I did it. Beautiful country. You'll find the information you need for scale and contour interval down here. Let's see, what else? Magnetic declination information is also at the bottom of the map. And I explained index lines. That's every fifth contour line. So we want to see, first of all, you need to know the contour interval and multiply that by 4, and then you'll know the elevation change in feet between index lines. And those are the bold contour lines that you see every 5 contour lines. You can pick any one of the rivers or creeks in the area on the map. Tell me from what you're looking at which way the stream is flowing, and based on the contour line shape, whether it's V'd in a certain direction, you can tell me what evidence you use to arrive at that answer. This part tripped up my students last semester, so I'm going to do better this semester and explain it to you. Now, some of you like to draw on your computer. Maybe you got an iPad, maybe you've got like a Surface Pro situation. Maybe you have that capability. Maybe you don't, so you want to print this lab out, and that's good. You see this, and I created this. I took a mountain structure in Michigan, brought it into Adobe Illustrator, using the elevation data that I had. I just dropped points of elevation on the map. This looks like nothing to you. It looks like connect the dots. We are not connecting the dots. We know what all this elevation is, and this is in feet. We want to draw contour lines around it. So to get you started, make sure I have selected this color. This is the highest elevation point I see, 1,460 feet. I suggested you use a contour interval of 40 feet. So how about this? You all start here and draw a contour line like this, enclosing it. And this is going to look ugly when I draw it, but I'm going to say that's 1,440 feet. You do not have to draw the, or you don't have to write the elevation that your line represents, okay? So you have that. Your next line down, because your contour interval is 1,440, would be 1,400. And in fact, we have an elevation point that says 1,400 here, so I can actually draw it through the point. And this is representing 1,400 feet. I put that contour line closer to this side because I see 1,265 here, quite a step down. I see 1,200 here and here. Okay, so that line is 1,400 feet. All right, contour interval is 40 feet. So I need to subtract 40 from 1,400. So that gives me 1,360. And I'll just put that in here. Start to draw 1360. Next line, 1320. And this can be messy. I don't care if it's like a huge mess. I just want you to do your best to represent what a topographic map is. I'm saying, like, if you printed this out, then you would probably want to use pencil. If you're doing it the way I do, it's easy enough to erase. There's like an erase tool right here. My next line would be 1320. Don't worry if this is hard or overwhelming at first. Because it's like we're looking at this mess of data and we're trying to make sense of it. I personally already know what the structure is. You don't. You're discovering it through your lines. So after that, you will subtract 40 from 1320 and put your next line in. Eventually, you'll get to 1200. I'm skipping a bunch of lines in between. And if I remember correctly, the way the lines work is your 1200 line will, I think you draw it through this one. So, like, again, anything on the inside of this is higher than 1200, right? Anything on the outside of that line is lower than 1200, right? But I want you to do it every 40 feet, so it's going to be a little crowded. Anyway, I think that'll get you started. Pay attention to the data out here. Some of it might not make sense. You might see like a little bit of an anomaly, like this point is the highest in this area, right? And I think this point is the highest in this area. So it's possible to have a mountain structure here and then it get lower, but then there will be some higher areas in here. Remember that contour lines do not cross. They represent imaginary lines of equal elevation. All right, so if you have any questions on that, get a hold of me. And of course, you're going to need to flip this page. All right. Part 3 could also throw you for a loop. I have a website that I wanted you to visit. The Carleton site is just incredible for geoscience education. I'll bring it up here. They explain it as well or better than I could, but I'll do my part too. So this is all about how to construct a topographic profile. We're connecting points to make a smooth curve. So a profile, that's like a cross section. With our topographic map, we're looking at it in map view, we're looking down on it like we're in space or whatever. So I gave you in the lab a line that's going across part of that Patrick's Basin quadrangle. And then I gave you these lines to plot data on right below it. So what's been done here, we have taken the value for elevation here and plotted it down on lines directly below. So effectively what you're doing, this is 40, right? This is 30, this is 20, and out here would be 10. You just take this data only from along the line from A to B, and you plot it on the lines below. And what that gives you is a topographic profile. So now we can actually see if we were standing on the ground looking at these mountains, this is what they would look like. So you can take some time to go through the Carleton site. How it works here. Maybe it's best to print this sheet out, but not necessarily do you have to. And I know there's a ton of lines here. So on this axis, you're going to plot a topographic profile on these lines, right? And it will look something like, let's see, we're kind of up here, going down, up again, going down until way down to point A prime. So if you printed this out, what you can do is actually fold these lines up until they're touching this line. And with a pencil, just make tick marks in the same spaces where a contour line crosses that line. Put the tick marks on this line, right? Figure out what the value of each contour line is. Like this one is 5,000. The contour interval here is 40. So you are subtracting 40 as you go down that way. And you'll know what each value each line has. And you're going to plot that profile here. And again, it'll look something like so, like going down here. So you'll have elevation marked here. I don't want you to write any values for distance here. But what you're going to be showing me and yourself is what this looks like if you were standing here looking at it from the side. So you're going from map view to topographic profile. And it's going to take a little bit of time, but I don't want it to be overly mathematical or difficult. Yeah, you can do a combination of looking at it on the screen, folding up the paper so that this matches up to here and you can just draw the spacing of the lines in, and plotting the values of the line here so you get a profile. And that's it for the lab. I am really happy to answer any of your questions, so get a hold of me when you have them. All right, and I will talk to you later.